So let's look at the biome. So our gut microbiome, as we talked about in many lectures before, is not just bacteria. It's that forest that's got all sorts of live dynamic organisms in it. And so when we try to replace one entity, one microbe or another by taking probiotics, we sometimes disrupt this finite balance. So we have bacteria and viruses and fungi and arachnae and helminths and protozoas and phages, and all these impact us and create that diversity that we need. The interesting thing is we are now learning these things called phages and viruses, which I've learned since the last time we did our biome lectures. They actually are being shown to actually manipulate the bacteria to help them become what they're supposed to be, but they could also cause harm to the bacteria. So these are very important new entities that we're studying in science to help us better understand how we can maximize our gut biome. Remember that most of the biome is in our large and small intestines, especially living predominantly in the large intestines, but that's mostly the housing. We do have bacteria in our sinuses, in our airways, in our eyes, in our mouth and our upper GI tract, but it's predominantly the lower GI tract, especially the large intestines, where these bacteria are mostly living. 90% of them are made up of this first two, the firmicutes and the Bacteroides. And then you see here that the firmicutes and Bacteroides break down into a subphyla. And so some of these can be inducing harm and some of them can induce health. But it's that balance, that fine balance, that actually helps us to maintain a healthy balance, and the dynamics of diversity helps us. Now, many of you may have heard about taking stool samples, and they study stool samples, but we're now realizing we can't study stool samples. It really doesn't relate to the disease process, but we rather got to go into the intestinal tract, find where the gut might be leaky or having inflammation. And in patients that have autoimmune diseases like rheumatoid arthritis or type 1 diabetes or type 2 diabetes, and they have a leaky gut, or they have neurocognitive decline like Parkinson's and Alzheimer's, we really need to go into the gut area, into the colonic area, and take samples where the thinning of that mucosa layer is becoming thinning and weak and leaky. And again, you guys can rewatch some of those lectures we gave on gut biome. There's been several of them. And what happens is when it gets leaky, the stool and these microbes, especially the gram-negatives, actually leak into the body, activating a systemic immune response. And if your genetic predisposition is to develop type 1 diabetes or hypothyroidism, you'll end up in that track. If your genetic predisposition is to have gut autoimmune like Crohn's and ulcerative colitis, you'll go on that track. If you are predisposed to having autoimmune disease of the joints, rheumatoid, psoriatic arthritis, or rheumatologic disorders, you'll go on that track. You may end up going on a neurologic track, accelerating neurologic diseases. So we don't want to study the feces. We really need to study the area in the gut that's thinning and not healthy, and what those bacteria in there are and how they might be able to be shifted. We don't have a way to grow one specific subphyla or another, but we do know, as we've talked about on previous lectures, that we want you to take in probiotic foods, and then your body will pull the ones that are most healthy and that they need more of abundance. This very interesting statement in one of the references that I was reviewing, there was reference to a fellow, Stan Hazen, who said, looking at the bacteria in feces is like looking at the rubble at the World Trade Center and trying to figure out what was a janitorial closet on level 63 floor having in it. So we have this diverse stool, but that doesn't really tell us what's happening within the lining that caused the leaking, or that may have activated the leaking and the disrupting of the mucosa. So that's the problem. And again, it's not the stool. We want to look really at the organisms and where that gut lining is thin. The gut biome is important because, as we talked about, it modulates not just three, I mentioned three here, but it's actually more than three. It's the immune system, And we'll go over the immune system next month. We're going to have a lecture on immunology and the gut biome and just our overall health and aging. The cardiovascular system. So we now know that the gut biome can activate and disrupt cardiovascular systems, neurologic systems, gastrointestinal systems, rheumatologic, and musculoskeletal. It's very important that we understand that damage and the thinning and the dysbiosis, that unhealthy bacteria that's leading to this leakiness that then is causing the disease. And it's the disease that is actually accelerating the aging. So when we go in and we try to help you change your diet and fix the diabetes, and then fix your weight, and then fix your blood pressure and fix your cholesterol and get you off the medications, we're actually slowing down your aging process. And many of you who lost a lot of weight are prolonging your life. You're actually giving yourselves back life by doing this and investing in this. And this is why it's not easy, because we fall off the wagon, because we go back into society, we start drinking, we start eating unhealthy, we stop exercising, life gets stressful. That's why we do the coaching here at Shield of Life. So here's a closer look again at that barrier. So here is the one side of the wall of the gut. And so what happens is, here's the biome. Let's just go through some anatomy here. Here's the biome. Here's your intestinal cells with little villi at the top. Sorry, I'm not an artist, but this is my rendition. This is the epithelium, that superficial layer at the top. And then top of that layer, there's these barriers. There's an outer and inner part of that mucosal layer. And then you have the muscular layers. There's 4 or 5 muscular layers here that increase that contractility of the bowel as it moves. So what happens is, when the bacteria become dysbiotic, meaning unhealthy bacteria, a lot of them are made up of gram-negative organisms. Most of the organisms that are healthy in the gut biome are anaerobes. They're not oxygen-demanding bacteria, they're anaerobes. But gram-negative bacteria actually have a coating on the outside called LPS, or lipopolysaccharides. And we can determine, based on the lipopolysaccharide count, how much someone's leaky gut, or someone's gut is leaky. Now, everyone can do these tests, but this can give an indication of someone's degree of leaky gut. So not all gram-negative organisms are bad, but when there's an abundance, it is definitely associated with disease. And so these bacteria hang out in the visceral fats. When people come into my office, I actually put them on a body composition scale, and I can measure the amount of visceral fat they have. And that's the fat that's sitting around that omental layer. So we have our intestines, and then on top of the intestines is a covering we call the omental layer. And then between that is where the fat is. And that's the driver of disease. So again, did the disease start from bad bacteria that we were born with that continue to get worse? Or did we start with a healthy gut biome, and then because of antibiotics and medications, which you'll learn about in just a minute, and unhealthy diet and inactivity and not sleeping, did that then propagate disease? And it's really both. It depends on the disease state and that brought about.